Hey y'all, we are going to continue with this 12.1 lesson. I'm actually going to get all of this to go away. Excuse me. And that right there. Let's scroll back up, see where we're at. So we're still on 12.1. What we just now did was we used exponents. That's our last video. What we're going to do right now is we're going to look at the product rule. Okay, so if you look on our little green table there, the top left one says product rule. And I'm going to explain this very thoroughly, okay? It is kind of small. You can get this from your book. It states A to the M times A to the N. There we go. Look at that. Haha. A to the M times A to the N equals A to the M plus N. Okay, again, this comes from your book, and you can look at that. It does have its own example. Okay, I'm going to do an example. I'm actually going to swipe up, and we're going to do a couple of examples. So this, y'all, is what we call the product rule. Product means multiplication, right? Product is actually the answer to a multiplication problem. Now, whenever you are multiplying exponents together or even multiplying bases together, if you have the same exponent, you apply this rule when you multiply them. If you have the same base, you apply this rule when you multiply them. The product is the answer to a multiplication problem, so it's letting you know when you do the multiplication, this is the rule you need to have to use so that your answer, your product, is correct. Okay, and so what it is A to the M, I cannot stop doing that, y'all, times A to the N. Do not use an X here. That's actually a multiplication symbol. When we use the dot, if you use an X, it could look like another variable. It'll confuse you. Okay, so our product rule states that if you have the same base multiplying each other, so do you notice that's an A times an A, right? That's why I can apply this rule. What you do is you keep your base and you add your powers, okay? So let's do this example here. I'm going to do a couple of examples. One's going to be using an actual base with like a numerical value, and then we're going to do an example just using exponents, and then we're going to do an example with a combination of both, okay? So say for this first problem, what we have is 6 raised to the second power times 6 raised to the fifth power. Here, our 6 is in the place of our A. So do you notice how the product rule states that if you have the two terms and those A terms, whatever they may be, if they're the same, A is A, right? Here, 6 is 6. Those are the same. They have the same base. Because they have the same base, what we would do is look at the product rule, and it states, keep your base, add your powers. Keep your base, add your powers. You get 6 times 7. Y'all, this is not 6 times 6. Oh, let me add the 2 and 5 and you get 36 to the 7th. That's not correct. Okay, the 2 exponent is with the first 6. The 5 exponent is with the second 6. So because those aren't just the number 6, you don't just multiply them together. Okay, you follow the product rule, which states keep your base, add your powers. Okay, so second example, say we have x to the 6th times x squared. Do you notice how my x's are the same base, right? Same variable. So what you do is you would keep your variable and you would add your powers, add your exponents. 6 plus 2 equals 8. Okay, I'm going to do a little side example that I wasn't going to do, but say the problem looked like x to the 6th times x squared times times y to the 3rd power, y cubed. If you notice your x's, those are the exact same variable. You can apply the product rule here. You can keep and add. Your y cubed is not an x. It cannot be added with the other x's. It would just stay y cubed. Okay? Now what about this problem? Say we have 2x cubed, and then we're going to multiply that with 3x to the 7th power. Okay. So what we do here, the product rule is applied to your variables. You would not look at the 2 and the 3 and say, oh, those aren't the same, I can't do anything. Your product rule is going to be it's going to be applied to your x cubed and your x raised to the 7th power. Those are the exact same variable. What you do is you keep your variable and you add your exponents. What you do with this particular problem, because we have coefficients of 2 and 3, is your 2 and your 3 get multiplied together. So I'm going to show you the answer, and then I'll show you how you could do it the long way, okay? I just wouldn't recommend the long way if you don't have to do the long way. Look at your coefficients. 2 times 3 is 6. X cubed times x to the 7th. My product rule says to keep and add. I would get 6x to the 10th. Fairly a short process right there. If that doesn't make sense to you, what you can do when you have 2x cubed times 3x to the 7th is 2 times 3, and then we have times x cubed times x to the 7th. 2 times 3 is 6, x cubed, x to the 7th, keep and add, 6x to the 10th. That's a little bit more thorough, each step being explained and each step being shown, but these problems on the homework and on exams can get rather lengthy, so your best bet is going to just see that you need to multiply these coefficients to get our 6, and then our actual exponent rule is applied to, exponent rule. Our exponent rule of the product rule is applied to the exponents attached to those x variables, okay? Okay, so that was the product rule. I'm going to close this video and I will come back with some power rules. If y'all have any questions, make sure y'all let me know, okay? Bye.